I'm just going to briefly show this. These are just some formulas to remember because we're about to get into our last three problems which use some of these formulas. So they're just different volume formulas. So a cylindrical container, in this case, so we've got a cylinder, is 12 inches tall. I'm actually going to go ahead and draw a picture. So we've got some cylinder that's 12 inches tall. That was an amazing picture. And the diameter, so all the way across, is 4 inches. So 1 cubic inch of the container can hold 2 marbles. Okay, so that's interesting that they told us that. What they just told you right there is actually the density. So you can have 2 marbles per 1 cubic inch, or 2 marbles, I can write it this way, per cubic inch. Okay? So this time we're actually trying to find the number of marbles. We're looking for the population that can fit in the jar. So before we can find the population, we do need to find the volume of this cylinder. So if you look back on this, remember it's pi r squared times height. So pi, our radius is 2, because you do half of the diameter. So 2r squared times our height, which is 12. And that would be 48 pi. We'll simplify it later after we get our, and let's do our cubic inches. 48 pi cubic inches. So afterward, we're going to go ahead and find our population by putting in our density, and that's equal to the population over our volume, which you would then solve. You'd find the population by doing 2 times 48 pi. And when it comes to populations, you don't keep the decimal this time because it is a population. You don't say there's 0.5 or 0.2 of a marble in there. So this is about 301 marbles when you calculate that. Sweet. Let's do another. This one we've got a florist. Florist recommends that you should grow 8 tulips per square foot. So that's a density because they're saying it's 8 per square foot. So for tulips, we've got a density of 8. I'm going to put T per square foot. And then for lilies, I'm just trying to organize it, our density is 2 lilies per square foot. I'm just simplifying. So we want to grow 50 tulips and 50 lilies. So that's our population. We want 50 of each. How many more square feet of garden space do you need for the lilies than for the tulips? So there's going to be kind of 2 parts to this. So we need to first figure out what our area is for each one. Then we can figure out how much more the lilies will need rather than as compared to the tulips. Okay, so remember density, if we go ahead and solve these, density is your population over your area. Oops. And so we'd have 8 is equal to 50 over A. Therefore, A is just 50 over 8, which is going to be, I don't know why I put the approximate symbol, because it's going to be right on 6.25 square feet. And then I could do the same thing for the lilies. And in fact, you can just skip over to say A would then be 50 over 2 this time, which is 25 square feet. Now, that's not what the question's asking. The question's asking how many more square feet do you need for the lilies as compared to the tulips. So you're just going to go ahead and subtract the square feet, and you get that you'll need 18.25 square feet more. Oops, that's a really bad M. All right, let's do one more. So we've got a 5 feet by 2 feet by 1.5 feet. So if they give you those dimensions, it's telling us this is going to be a rectangular prism, something like this. So it's 5 by 2 by 1.5. And that holds 20 fish. Okay. Let's actually, well, we know we're going to have to find the volume, so why not just find it now? So 5 times 2 times 1.5, so you just multiply all those together, will tell us this is 15 cubic feet. And it holds, so the population is 20 fish in this tank. Which we'll probably need the density, so why not find it? So the density would be 20 over 15, so 20 fish over the 15 cubic feet. And I'll just simplify that down to 4/3, because we'll probably use that later. In fact, yes, if you read the next thing, it says based on the population density, so based on this, on 4/3, how many fish can an aquarium in the shape of a cube hold, with 2 feet edges hold? Wow, I can't read. So we got our cube one then. So cube looks like so. So it's 2 by 2 by 2. Oops, I did 2 of them on the same spot. There we go. 2 by 2 by 2. So the volume of the cube aquarium, so I'm going to call this tank 2. The volume of this one is 2 cubed, which is 8 cubic feet. And we are trying to find the population based on this density. So I'm just going to go ahead and take that density. So I have 4/3 is going to have to equal our population over 8 cubic feet. And we could cross multiply to solve this. So we've got 3p equals 24. And that is not 24. Try that again. So it's going to give us 3p is going to equal 32. There we go. That sounds better. And then you divide both sides by 3, and you get that the population is 10.6 repeated, which we don't want. So our answer would be 10 fish. We don't want that 0.6. We don't want to overcrowd it either, so we just round down.